Cool. So now we have some ideas here on the spreadsheet. So throughout the week, when you come up with more ideas, go ahead and put them here. Um, and then this will help us kind of on this survey next week when it comes to filling out here app ideas. Right? We can then use ideas that we found from this spreadsheet. Do you mind door? So just go ahead and I'll send out some reminders in Slack or Facebook, but go ahead and add some ideas here. Great start today. These some great ideas, and hopefully this gives us something to work off for the next few weeks. Cool. So now let's get to testing. So this week's assignment is we're not gonna start from scratch anymore like we had before with Rails New. We're gonna kind of go and use an existing application. A few things to know. So last week we did user authentication from scratch. Going forward, we'll be using Devise for most of our user authentication, and Devise is something we all worked with during the pre-work assignment. It's pretty handy. It does a lot of things we did automatically for us. They have a bunch of modules here, and so you can. The most basic one is just storing the hash of the password in the database. You can also add an OmniAuth support. So some people saw last week started adding Facebook or GitHub login. You can use that with the OmniAuth. You can send emails. You can reset the password. You can track who's logging in via their IP address. You can expire sessions that have been inactive for a certain period of time. So I think a few people have questions about expiring sessions, and so this would be a good module to check out. You can say if the user hasn't logged in for 2 weeks, go ahead and log them out. A pretty reasonable README here, kind of a lot of information. A few things you might notice is, right, similar. They have a before action here, right, authenticate user. So to verify that the user is logged in before they keep going. They also provide two functions which look very similar to what we did last week. So they have a user signed in and a current user, right? And we kind of implement this a lot from scratch last week. But now going forward, now that we all understand how it works, we can start using Devise. The other few things is there are a few questions about redirect to versus render. So in our controller, right, in some places, this is just the thing I had from last week, the application, and let me see if I can pull up. Right, so example in this function, right, we have both render and redirect to. What's the difference? So a render tells the client, you sent up a certain action. In this case, it's a create action, but go ahead and render on the client side, right, the form for new. So in the response back from the server, it gets the view associated with the new action, right? So it's the same request, still one request in, but the response tells the client to render a certain view. The difference with redirect to is when the server replies a redirect to, it's actually not a 200, it's a 302 request response. And 302 means redirect. So it's telling the client, send me a different request to this new action, right? Send me a different request to the action specified here. Right? Does that make sense? So the render is one request. The response is just a different view than the action. A redirect is a 302 response, and it says, go ahead and send me now a new request pointing to a different action or different controller or wherever with maybe some new information. Is that clear to everyone? So there are different use cases, right? So one of them is we create a user, right? We sign them in, and then we go ahead and just show that, right? We take them to a new page, like the login page or the home page. The other one being, go ahead and reload that page, or reload a different page, because we need to set up new information, or it's a different controller. We don't have access to that in this page. This render is pretty powerful though. So here, right, just as it's the new action. You can specify a partial or a different view. So if you have like a layout, right, and you have like an error page, right, you can like render, something like that. So there's a lot you can do with them. You're not just confined to the views on this controller, but it's typically when you want to just go ahead and render a new view with that same response as opposed to redirecting them. And the last thing is some people had questions about debugging a controller, different ways to do that. So the most basic method, right, is you can just do output statements. You can just say puts, something. You say, params, and print it out. And then in your server logs, right, when we run Rails server, you will see this output statement. That works. It's not super handy, but sometimes in just a quick bind, you want to just print something out and see what happens. You can do that. You also may notice in the gem file, there is a gem called bybug, which is super handy. So if you haven't checked it out yet, I would encourage you to check it out. But essentially, as this comment says, right, you could just put bybug in the code. So let's say I'm like, how does this controller work? I can just type in bybug, right, and go ahead and run it. And when I hit this action, it'll open up, essentially, it'll stop execution at that line and let me interact with the code. So I can step through it. I can say continue. I can inspect things. It's essentially adding in a breakpoint to the line of execution. And it's a gem that is nowadays comes standard in development and test. So you can use it in both environments. But it's pretty handy to kind of inspect things, play around with things, and see what's going on. So both of these are great ways to kind of debug a controller and see what's going on. And this actually leads well into what we're talking about today is how do we know things are working, right? How do we know that it's actually doing what we want it to do? And in the past, how have we done that? Usually with the Rails console, right? We'll go to Rails console and we'll inspect things and say, how many users are there? If I create a user, did it give it the right fields? That sort of thing, right? Or we did via the UI. You refresh the page, the UI now shows what you want it to show. Fantastic. But that only works, at a small scale. The really way you want to start, testing things is via automated tests, right? Or let's say you have a route, right? This is a router, right? Great. We say only give us these routes, but someone happens to go in, maybe it's a bad merge, or someone doesn't, they want to change something, and they decide to just delete a route, right? They delete the new route, and all of a sudden, maybe they already have an account, so they don't have to ever sign in, right? They've already signed in before. They won't know it's a bug, right? They've introduced now a bug to the project, but they don't quite know that because they never have to actually try that action out. So how do we catch those sorts of things? And that's what we call regression testing. How do we, write tests that then make sure that the features that we've already implemented don't break, right? It's easy to add in a new feature, but it's harder to make sure that it also not only works, but it also doesn't break other functionality, right? And that's why testing is really key. And in Rails, we do a lot of unit testing to test our code. There's also a lot of tools for integration testing. Integration testing is a little more difficult because if your UI changes, now all of a sudden your tests aren't as compatible, and so you kind of have to think about that. But unit testing is great because it really kind of boils down to the core logic about whatever the application of the business is. And so today I'm going to kind of focus a little bit on that and work through some Rails tests. So the assignment for this week is coder ticket. It's kind of just a shell of an application. It has some existing models, and these are the models here. So if I just take a moment just to understand what the models do, right? There's an event, which is like an event you can purchase a ticket to, so like a concert or a show. An event takes place in a region, right? So an event, that means belongs to a region. It also belongs to a venue. And this probably means actually that the event probably belongs to a venue, and then the venue belongs to a region. There's also a category, right, or a type of event, so we can filter easily. And then there's also a ticket type, so and a ticket. But you need to know what type of ticket there are and what type of ticket you're buying. So this is just the basic kind of model relationships that we have for this week. Does that make sense to everyone? Make sure everyone understands that. Cool. So let's go ahead and get started with some. All right. So here I cloned the repository, and I'll run bundle as always, just to make sure that we're. Get into it. Right. Pretty standard. Great. So here we have our database schema, and you can see the migrations have already been run. So we have. Right, categories, just a name. We have some events, which are some timestamps, some images, some HTML, some categories. Regions has a name. Ticket types, right, has an event ID, which suggests a foreign key relationship. There's also a price, a name, a quantity. And finally, there's venues, which is an address, and then the region it belongs to, and the name of the venue. Right, so the database is defined as thus. But since we just cloned it, right, if we actually look at our database, we haven't created these tables because we haven't actually loaded in these the schema. So what we could do is we could say Rails, right? What db create, db migrate, and db seed. Right? It's essentially what we're trying to do is create the database and seed it. But Rails provides a command in there for us actually, and we can list out here all the different commands. So let's just see what the command is. And Rails-T is a way to list all your different commands. And here we see Rails DB setup says creates the database, loads the schema, and initializes it. So essentially, it's the same thing that we just saw. It's create, migrate, and seed. It also says here it uses DB reset. So in case there's an old table with the same name, it'll drop it. And let's just verify that we actually have a seed file. So here is our DB seeds file. Great. It creates some default regions, some categories. It creates some events for us and gives it some HTML descriptions. Right, fantastic. It's a seed file. So we'll go ahead and run that Rails DB setup. And then we'll go ahead and create our database for us. And it's going to initialize it. Great. So now we have our database set up, and it added all the tables in, and it ran DB seed for us. So first we're kind of going to cover the basic Rails way of writing tests, which is through active support test case. So let's inspect here our folder, and we don't yet have a test folder, so we'll make one. And I'm just going to create a model folder just so that we have some organization. So if we get into the test folder, oops, we're going to make it in the test folder. Okay, so now if we go into the test folder, we have models. Great, we'll go into models. And let's just write a basic test for an event or a category model. So, a category test. Cool. So here's a category model, right? It basically says, we have some validations. The name belongs to one of 3 categories, and it validates the uniqueness of the name so that we don't have overlapping. So we want to say, let's just write some tests and ensure that the validation is actually working as expected. So we're going to define a test, and we're going to say it inherits active support test case, which is just the standard basic Rails test. And actually, if you look up active support test case, this actually inherits from MiniTest, which is a popular assertion kind of framework for Rails. And so we're going to cover this first. So let's just say we want to test out the validation, right? So we're going to say test validation, and we'll say on presence of name. Oops. And for our model, right, we say validates inclusion of name in one of these, basically in this array. So let's just test and make sure that's actually working as we expect. And so we'll kind of just write a basic test for that. So we're going to want to probably create a model, right? So create a model. And then let's just go ahead and say, if we try to save it, what's going to happen, right? So we'll call category.save. And remember how we said with the bang, it throws an exception, right, if it is unable to? But just save by itself returns true or false. So in this case, we expect the creation to fail because it doesn't meet the validation. So we'd expect a false, right? But let's just verify that the test is actually working. So we'll say true for now. And let's go ahead then and run the test. And verify that we get a failure so we know that it's actually working as we expect. So we're going to start the test up. Let's see, let me just wait. Huh. Load a console. Okay, so load the console. Can we load the test? There we go. Cool. So here we say, fantastic, right? The test ran, just one test. Test validation on presence of name. Expected false and actual true. Fantastic. So that means that our test is working as we would expect it to. We can add an error message at the end, and this error message will get printed out if the assertion fails, right? So we'll say should not be able to create or save a category without a name, right? And if we run it again, when the test fails, it should print out that handy thing, right? And here it says exactly what we said. Should not be able to save a category without a name. Cool. Working as expected. So we'll actually make the test pass this time, as we think, and we'll say, let's test the inclusion, right? So validation on inclusion of name. And remember here we say, right, the name has to be one of these three things. So let's just make sure that's actually working as we hope. So again, we'll create a category. And we'll give it a name that is not in that set. And this time we'll also do the same thing. Right? We'll try to save it. And it should be a false because the name is not in the inclusion. Great. Should not be able to save a name that is not in the inclusion set. We also can test even more than that. We could say, let's test what the actual error is, right? So remember we have a category.errors, right? And you can inspect things. You can say, like, what's the errors on the name? So we'll just make sure that the error is what we expect it to. And so we say, let's look at the error that comes from the name field. And we'll say is not included in the list, right? And that's what we'd expect the Rails test, the validation to tell us. So fantastic. Our test passed. This means that they're looking pretty good. We've only kind of invalidated things. We actually haven't created something that works. And so let's finally make sure that the test works. And a lot of times I like to at least write things in separate blocks. The reason is if an assertion fails within the context of one block, it stops the block and just says it's failure and goes on, right? So let's say you have multiple assert equals, right? You have, 4 or 5, and the first one fails. You don't know yet if the other ones would also fail or if they would also pass, right? Let's say you fix the first one, but then the third one fails. Now you fix that, and then right, yada yada. I think it's generally good practice to write them out in separate blocks so that it'll run each one every time, and you can immediately on the first run through figure out which ones worked and which ones did not work. So we'll just say a valid name works, and we'll create a valid name. And from our list, the names are entertainment, learning, and everything else. So we'll just say name is learning. And save it, and we'll make sure it works. So finally, we'll run the test. So we tested now both the case that it doesn't work and the case that it works, which is good. That means that we are feeling pretty confident with our testing and our validation on the category object. And that is kind of how MiniTest works. MiniTest is pretty popular in the Rails community because you can define these assertions. You can basically compare two things. Typically, the first one is the expected value, and the second parameter is the actual. And I've done it backwards here. And it's easy to kind of forget which one is which is one downside to MiniTest because the expected versus the actual kind of gets confusing in this context. You don't quite remember, or you may forget which one comes first. So we actually, for the rest of this week, we'll be using RSpec, and RSpec has more of a specification style language. So you don't quite say as much assertions, but you describe what you expect to happen, and then it tests that for you. And there's reasons that RSpec is popular. One is it's readable, it's very easy to read, and we're actually going to pull up the gem here. So this is RSpec, the Ruby gem. The way you add it is just simply adding it in the gem file. And it comes with a nice generators, kind of in the Rails way. So you can say, Rails generate RSpec install. And you can run a series of tests. You can run only one test. The reason we want to use RSpec, at least for this course, is it's very easy to read because it's not like an assertion language, but it's a domain-specific language. People tend to be happier when working on RSpec. It's a little subjective, but there's a lot of friendliness toward developers. It's very mature. There's a lot of different gems that support it, and it's pretty commonly used. It's used in a lot of jobs as well, which is I think why we're going to teach it this week. But it seems to be pretty well liked. Again, MiniTest is also used as well, so it's not like a complete one way or the other. Both are used, but we're going to go ahead with RSpec. So let's go back to our gem file, and let's see if we have RSpec. And we have it here. There's also a nice gem called Simple Cov, and I encourage you to check it out as well. It's a coverage testing tool. So it tells you when you run your test suite, how many of the lines of code did you actually hit via your tests, and how many lines of code did not get run. They have a nice kind of HTTP web interface. You can see your code, see which lines were run, which lines were not run, how many, what your percentage is. Very simple, very easy to use. Works well with RSpec and MiniTest actually. So we have our RSpec gem here. Great. And the next code it tells us is to go ahead and install it. So let's go ahead and set up our RSpec. And it looks like we already actually have a spec helper, so we're not going to overwrite it. Great. So now let's spec thing. So we have a spec helper, which is essentially a config file for RSpec. There's some defaults in here. You'll notice that it already includes simple cov for us. Fantastic. A lot of comments here as well. A few things I want to cover is verify partial doubles. Essentially, it lets you stub out a function in your code. Maybe you have a function in your code that logs into Facebook and it calls the Facebook API, right? But in your test, you may not actually want to call the Facebook API because what if, for some reason, their API goes down or the API changes? Now, all of a sudden, you're relying on their response. Maybe you want to do that. Maybe you don't. And if you don't, you can write a function that essentially stubs out that functionality. So it's a dummy function that just returns a response. And so you're not going to really test that function, but you're testing some other components that rely on that functionality. Similar with emails, it's really hard to test like an email with like delivered and seen, but you can stub it out and say, send an email to this fake account, make sure this fake account actually got the email and such. So this config here makes sure that you can only stub out things that actually exist, and you can't create a stub for something that does not exist. It's to help kind of ensure testing accuracy. There's a bunch more down here. One of them is disable monkey patching so that you can only override certain things. You can choose to randomize the order which the tests are run, and that's actually pretty recommended because in case there's a case when a test relies on another test having certain things, right? You want the test to kind of be self-contained, and so you can randomize the order that the tests are run via this line here, if you uncomment it, essentially, and that just kind of helps ensure, again, testing accuracy. One thing to note about RSpec is each test is its own database transaction. So when you run a test, at the end of the test, it'll undo all the database transactions that you just happened so that each test kind of has the same blank slate. There are ways to kind of create helpers to create things quickly, but it's kind of nice because every test has a clean slate. Alrighty, so we ran install. We also now can actually run, so RSpec comes with a lot of handy things, and we recognize this can, right? Rails generates scaffold from before, but RSpec also integrates with scaffold. So let's just say we want to create a person, as an example, and we'll give it just two basic fields. If we create this using a scaffold, you notice now it creates not only our model and our resources, right, and some views, but it also adds in some testing. And here it adds in some specs for the views, some helpers, which is pretty cool. So RSpec integrates well into the existing Rails framework. We actually don't need a person model, so let's go ahead and undo that operation. That was just kind of an example. Great. So we have our initial file set up. We added some test files. The testing we added was some MiniTest, so we'll go ahead and remove those. And now let's start to write some RSpec. So the way that you'd run RSpec is bundle exec and RSpec. And if we run that, let's ensure that it actually works. Great. And it says no examples found, right? 0 failure examples, 0 failures. That's just because we have no tests. So if we inspect the spec folder, we'll see a bunch of folders. It's great. But each folder essentially right now is empty. Right? All the folders are kind of just there for organization, but there's nothing in each one. But the way RSpec works, it'll run any file that has _spec.rb, right? So as long as it's inside of the spec folder, if it contains _spec, right, .rb, then it'll get run. So the files, the folders, they're just for organization. to help us kind of get things set up. So we go to the spec folder and we want to create a model test. So we go to the models and there's nothing in there. So we have to create something. One other thing to note is I ran bundle exec RSpec, right, to run the test, which is a little bit lengthy. There's a shortcut, and this is listed, I believe, in the README. This command right here. If you run it, it gives you access to a shortcut, so then you can just run bin RSpec. So if I run just bin RSpec, there you go. Thank you. And I'll run bin RSpec, and there we go. It runs the test for us. So that's just a nice convenience listed in Gemfile. So now that we have RSpec set up, let's start to write some tests. So we're going to go ahead and create a file, and we'll put it in spec. Let's go ahead and create a routing test first. So we'll just call this upcoming. And if we remember our models, right, we have an event model. So we want to say, let's go ahead and find all the upcoming events. So we're going to first need an endpoint that kind of handles that. And this is in the routing folder, but we're also just going to be sure we're going to specify the type. Okay. Great, so we have our test set up at the top, and we can kind of define describe blocks, which are handy helpers that kind of describe, like it sounds like, what we're trying to do. So in this case, we already have one describe block up here, right? We said routed to upcoming, so we won't add more to it. We do want to say, all right, let's test something. So we want to say routes the upcoming endpoint to some action, right? So we're going to say it routes it to events index. And we'll just basically, when users log in, show them all the upcoming events. And so what would that look like? Well, we'd expect if we send a get request to upcoming, right, to route us to some action. And this is kind of how RSpec, right, it's no longer assert equals. It's more, I expect something to do something, whether it's to equal something or to take me someplace or to compare things. In this case, we expect us to route us to a certain action, right? And so the action is defined in the controller, and it has an action attached to it. And again, let's just make sure that we actually verify that this test works. So ideally, we want to send it to the index page, but for now, we'll send it to new, which means we also then need to define a route. So we have all this boilerplate stuff here. We'll get rid of that. We have some routes. Let's go ahead and say let's route upcoming to where, and we said we want to route it to events index. Great. We'll go ahead and run our tests, and we expect it to fail, and it did, right? Except this time it failed with an undefined method. Let's see what our test looks like. Expect get upcoming route to describe. Undefined method. Tree. Right there. See, describe it. Routes upcoming to right here. Oops. No, I still didn't see it. Undefined method route 2. Let me make sure I defined it correctly. Take a look at the documentation here. Should. Oh. Still didn't work. Ah, yeah. I think it's Rails helper. Underscore. There it is. Thanks, guys. Alrighty, thank you. So now, right, great. It says expected. Let's see, recognize options. So expected is an index did not match new, which is good, right? Because we purposely want to make sure it failed. So now we say, all right, we route it to the index route like we planned, and now with any luck, our test will actually pass. Great. Cool. Thanks, guys, for saving me there. And so that's our basic routing test, right? Pretty basic. It kind of just ensures that if we were to modify the router, function or the routes later, we're not going to delete old routes that exist as we want them to. The bug also kind of showed to us that it's, I kind of created that file from scratch, but you also could create it via the RSpec way, which is Rails generate. So there's always shortcuts for things, and Rails going to generate, and you could have generated router. Let's go ahead and generate now a controller for our events. And now we have our file, events controller spec, great. And this is the controller, and we'll open up the test as well. And luckily it has that part already for us, fantastic. So now here's our controller, and very basic, right? Not a lot of business logic for now. Let's just make sure it actually responds to things and that it can find things in the database. So we're just going to describe, and we're just going to describe the index, right? Get index. So let's just write a few basic tests that hit our index with the get request and make sure that it returns the right thing. So the first one is, let's just make sure the endpoint is up and running and responds with 200. So we'll say returns at 200. You may have noticed that RSpec is very much like almost like writing out phrases. It's very descriptive. So we'll hit the endpoint, and we'll expect back actually, and we can call the response body, and we'll say we expect it to what? And we could say response dot status to equal 200. That works. But we'll use the helper, even going faster. So response to have HTTP status 200. And that reads nicely, right? If you're a developer looking at some of these tests, you see this, you can quickly kind of understand what it is that they're trying to do. They're saying, all right, hit the endpoint, and let's expect it to have an HTTP status of 200. So we can run our tests. We also can run just a subset of tests. So we have bin RSpec, which is all the tests. We could run a subset of tests. So we say only run the tests within that folder. And we'll do so, and it says, great, one example. We can even run just a certain file. I believe it's this way. So you pass in the path to the file, it'll run it as is. So if you want to drill down and fix one task before you run all of them, definitely a possibility. So great, our index, we'll run on the controller test here and returns 200. Fantastic. Let's go ahead and say, let's do a little more. Let's say it shows all events, right? Our index, just very basic, events.all. Let's make sure it actually does that though. So as I mentioned before, right, each block here, defined by these it statements, is its own database transaction. So if you want to actually search for things in the database, you have to define them in that context of that block, right? So we'll just create a new event. That's a new, and if we pull up our event model, there's a bunch of validation statements here. In this test, we're not, this isn't a model test. This is just a controller test. We don't necessarily need to fill out all these fields. We're going to make sure that we can actually create an event and get it back. So we'll pass in kind of a shortcut here and say, let's skip validation. We'll test those later. For now, let's just make sure we can get something back. So we'll say expect, and in the controller here, we define it at events. So how do we access that? Well, we can say assigns events to, and then equal, and we'll say event. Right? So we expect the event that we get back to equal the event which we created right here. And let's go ahead and run that and see what happens. And it tells us assigns has been extracted to a gem. So assigns, I believe a few versions ago, got removed out of standard RSpec, which is fine. It's in this gem. So essentially, if you wanted to use assigns, you just add it to your gem file. So we'll add it in. I think they did it because not everyone wanted to use assigns, especially as people start to use Rails as less of a full stack framework and more of just a web server for like a rich front end, like a React or an Angular. And so assigns wasn't as useful for them. But since we want to test, the actual variable that we return in the view, we'll go ahead and add it in. And now if we run the test, great, it worked. And so coming back here to our test, right, we have two basic tests. One is the index is at 200, it's up and running. And the other one is just a very basic, we create one event, save it in the database, and when we hit the index, we expect to get it back. Right, and these tests are pretty lean, but our models, our controller is also pretty lean, right? Very basic right now, nothing really complex going on. So we feel pretty comfortable that these tests are exercising pretty good execution of the code that we have, right? But now let's get to really the core of things. Is we talked a lot about how the Rails way is to put a lot of the logic into the model. It kind of consolidates all of the action down on the model and it keeps the controllers lean and the routes lean. There's many reasons to do that. One of which is it makes it easy to test because then you just test the model and then you know that everything uses that model and you feel comfortable with that logic. So let's now write a test for our events class. So we're going to generate using RSpec a test for event, and you notice that it again ends in _spec.rb so that it knows how to run it. Right? We could call this whatever we want to. We could say this is coder school _spec, and it will still run the test as long as it is contained within the spec folder and it ends like that. Great. So here's our event model, and here is our test. You notice it says pending. What does that do? Well, let's see. Let's run a test, and we're actually only going to run the model tests because we only right now are developing those. We're not as interested in running other tests, and this is for the sake of just speed and performance. It will say not yet implemented. So it doesn't register as a failure. It just registers as a pending, and it's kind of a nice like a to-do. If you want to write a test, but you don't have the time to do it right then, but you also don't want to forget about it, what you could do is you could lay out all the tests you want to write with the pending, 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 and then slowly one by one write those tests, and kind of start to implement things as they go. So that's just a nice helper as well that RSpec offers. So let's go ahead and write some tests for our model, right? So we have our event model, and we're going to want to test some upcoming events. So the first one is it should return nothing, right? Empty array when there are no upcoming events. So we expect if we call event.upcoming, right, what are we going to get? We expect to get an empty array. And you'll notice here that we have yet to write anything, right? This event class is very lean. There's nothing in it. And this is test-driven development, right? We're going to write our tests first, how we describe things, expect them to go. And then we'll go ahead and actually write the functionality. So here we say undefined method upcoming, and that makes sense. We have yet to write our method, so let's go ahead and do that now. So we wrote our tests. Now let's see if we can get it to pass. So we'll say self.upcoming, right? It's a class method. And for now, let's just say return empty. That's all the test really expects, right? What happens if we run our test? It's going to pass. Right, so we still have our pending. We also have our success. I'm just going to comment out for now the pending one. I'll comment it out. So when we run our test, right, it passes. But that's not really exactly what we should be doing, right? Because we really need some functionality here. We shouldn't just return an empty array. So let's write some more tests. Let's see if we can write some tests that force us to write the function as it should be. So returns one event. Let's say, all right, right now it's done. It returns an empty array. Let's actually make it return an event to us. So we'll create a new event, and again we'll save it. And for now, we'll say validation false. Skip all the validations because there's a lot here with extended HTML description and venue and stuff, and we want to just focus on what we want to test. And so in expect, if we call the function again to equal what? Well, this time we expect it to equal our event, right? The event that we just created. So we'll run our tests, and we expect it to fail in test-driven development style. And here we say, it's upcoming. The test failed. It returns one event. What the expected was and what the actual was just an empty array. And it tells us even in line 11 that we failed. And so now we're going to go ahead and update our function, right? What if we just say event.last one, right? Would that work? Yeah, right? We're saying just return the last event. So far we have two tests. The tests are very basic. Just says if there's no events, return to me an empty array. If there's one event, return the event in an array. And we've got our test to pass, right? But this is still yet not really what we want to do because we still, right? This isn't the actual functionality. So let's see if we can even keep going and write some more tests that force us to write our function as it should be. So now I'm going to say it only returns upcoming events, which is the name of the function. So we'll probably need to create a few tests and of different time periods. So it starts at, and we'll create one that was in the past. We'll do one that's tomorrow, so 1 day from now. And then we'll do one a little bit further out in the future, just kind of different points in time. So we can even say time.now plus 2 months. And Rails is really helpful with timestamps, defining when things are. So we have our events, and I'm actually going to rename these to A, B, and C. And you can say, I'm a fan of kind of keeping code simple, so I'll write a block that basically just says event.save validate false, right? So say for each one, go ahead and save it, validate false, because we won't quite yet hit all of our validations things yet, but we can test the validations in a separate function, right? This function is testing the upcoming events function, so we'll kind of focus on what we want to test on. So now, if we call our function, right, upcoming, what do we expect is going to happen? Well, it's going to equal something, and it's going to equal, yeah, exactly, B and C. But what if we say C and then B, right? We haven't yet defined an order. What will happen? Let's try it. Right, so we'll run our function, we'll kick off the tests, and here it looks like it, right, it's throwing some error because it's comparing 8 and 7, but here it sees 8, and basically looks like it's an out of order failure. So we're comparing an array to an array, and arrays have order. So I think if we did B and C as is, right, that should work. But what if we change the order? We kind of want to really not test things. Alrighty, let's see here. 11 and 12. We only got 12 back. And that is because our function only returns the last one to us. So our test is failing because we return only one event, and our test expects 2. So now let's go ahead and actually write something here. So we're going to say where starts at is greater than time.now. All right, so only events in the future do we really care about them for this function. So let's go ahead and call it. And this time, let's see, expected 13 got nothing. And if we look at the test here, it's upcoming events returns 1 event. And this is good. We wrote our function, but our previous test actually was incomplete because our previous test, this one, where we expect to get something back, didn't specify a time. So it failed. So if we specify a time on it, right, we say it'll start in the future, then we expect to see it come back when we call event.upcoming. And now when we run our tests, they all pass. But having to specify the order of an array isn't great because the failure could just be the order is not the same. So there's a handy convenience function called matchArray, which compares the elements of the array to the other elements in the array. And it basically is make sure that they have the same elements. So if we run our test again, right, it still should pass. Cool. So what have we done so far, right? We wrote a basic test for the router that say if we hit this action, hit this URL, route us to a certain action. Great. We tested the action, make sure it returns to 200, and it returns to us events in the database. And we finally tested the model, and we say, all right, let's have a function on it and make sure it actually does what we want it to do, that it returns nothing if there's nothing there, and it returns to us the upcoming events as we've defined here. Now, if we want to write more tests, we obviously will, but let's say, here we're creating some data. And in future tests, we may need to, create a bunch of data in every test, and it may become cumbersome to do so. So you can define a before, and the default is before each, sorry. So before each block gets run, it'll call this block before and run it. So here we can say, for example, let's go ahead and create some, right? We'll go here and, create some data and save it. And that way, if we have different tests, right, rather than replicating all this code again and again, right, we can take it out and put it in the before and call it or something, right? So the before is just a nice way to kind of extract out all of your data creation. If you have a very similar use case, it depends. In this case, right, we don't necessarily need to do that because only one function is creating all that data, which is this one right here. Okay, are there any questions so far on what we've covered?
So every time you run the test,
yeah. So every time but notice it's not in the development database; it's in the testing database, right? So in our database config file, database.yaml, right? We have our development database, and there's also a test database, which is different, right? So if you really, I guess you could define this as a development database, but there really isn't a need to. But every time we run this test, it'll create these objects, these models, save them, run the expect line, and then it's all one database transaction. So it'll undo that, which means it undoes the transactions. Essentially, it deletes these objects from the database. Any other questions? So I wanted to cover a few other tests. So let's see. So right, we kind of covered some controller ones. So controllers have different tests, helpers you can run. So You can say, have HTTP status, which we use today. You can expect it to render a certain template to make sure that the view is hooked up properly to the controller. Here, using assigns, similar thing. It's creating some objects and then expecting them back. And you can even call redirects. So if you hit a certain action, maybe you log in with the user and you hit the endpoint, you expect it to redirect you to the home page, right? Or if you're logged out and you try to do something, it'll redirect you to the login page. And you can write tests for all that and you expect it to log in, or expect it to redirect you to. Same with view. We didn't go over view spec today, but you can write specs for views to render templates. You can look at certain views and make sure it includes certain words. Oops. You also can connect RSpec to Capybara, which is an integration testing, which lets you kind of do more nuanced UI testing. So you can say, expect there to be a certain element on the page. You even can manipulate the element. So you can say, maybe take me to the sign-in page and go ahead and fill in like the username and the password fields and sign me in. These are the routing specs we kind of covered, right? Expect us, if we go to a certain URL, to take us to a certain controller and a certain action. You even can say, expect it to not be routable. So expect if we hit a certain endpoint that it actually doesn't know how to handle it. There's no route that's set up to handle it, which is kind of good for security in case someone tries to, maybe you have to find some routes you don't actually need, and someone can see some data you don't really want to show them. You can write some tests to ensure that consistency. You also can write some helper specs. So if you have helper functions or helper classes, this one is a helper that's defined basically for the view to render a URL and an image. But behind it, if you click on it, it renders a link. So here, right, we create an event, and then we go ahead and expect, if we call on the helper function, we expect it to match some output. And this is starting to get into what the view looks like. And here is adding in Capybara. And I believe it's very simple to add in with RSpec. You have to just add in the gem, and that's all you need. And here we start to use some user manipulation, right? So we visit the login page, and we're filling in the username field, the password field. We're clicking on a button, and then we expect the page to, the next page to have some CSS elements on it, or to do some certain things. Right here, this test is we're creating an event, we're creating a ticket, and then we're visiting it and trying to buy it, and we're making sure that that process works and it has some text. So Capybara gives you a lot of functionality to start playing around with the user interaction and testing that user experience. So that is RSpec in a nutshell. A lot to cover, but I'll post a lot of these things online as a resource. There's a lot of documentation for RSpec as well, and I believe if we just Google it, here it is. The Relish app is really good documentation. So you can start to look at, API documentation. So let's just look for like a controller. All right, let's see what type of helper methods there are. Check out the controller spec. And it kind of tells us how to stub out view, anonymous controller, how to bypass an exception rescue. Right, very good documentation, worth checking out as well when you write some tests. So yeah, any questions? Okay, I know there's a lot to cover. Again, we'll post a video online and recap online as well as all this documentation. Lab again on Wednesday. Similar thing, pair programming. We'll do some implementation and some tests. If everyone's we after on Wednesday, I think we also should go out and get some beers or something at a bar. So if anyone is free afterwards and wants to hang out, we can go to a bar, grab some drinks. If you're busy, no obligation. But hopefully after Wednesday we'll have some time to just hang out and get to know each other.
Doesn't mean we can turn it.
It does not. There's still a number of days from Wednesday through Sunday. But maybe you'll be happier to do the homework. I don't know. How many tests is enough? That's a great question. The short answer is there's never enough. If you look at like mature companies, I think some companies have done some studies of how many tests they wrote, and over time, it's usually like a ratio of 4 to 1, like 4 lines of tests for every line of code in the database. Um, uh, so testing is really handy because as you start to develop more and more of a project, you want to make sure that your old stuff still works with confidence. And the easiest way is with a mature testing suite. Now, you don't want to spend all your time writing tests and not be able to develop. So it's more of a heuristic. Like it's kind of like how much you think is enough to write. But you can usually write more tests. But you essentially want to make sure you test the main functionality. You test that it both works when it works and it also doesn't work when it's not supposed to work. Right? You test both scenarios. So you test the positive and the negative. But we can discuss testing strategies at length. Um, yeah. So for this assignment, uh, say it again. In this course, yeah, it's more about getting familiar with the routine of testing and kind of getting a habit of testing early. Um, Here are the requirements for this assignment. Right? Never simply think of how many tests you should do. It's more about testing functionality, right? Do I feel comfortable that this part has been exercised properly? But at least for this assignment, we have like a number of tests to write. Like I said, don't worry too much about like very UI heavy tests, like should this element be beneath this element with a factor of 10 difference? Because if you decide to change UI, right, you want to imagine how things look. Now that's out of date. And if the test becomes quickly out of date, it's not as useful, right? The most important part, as you can tell from these numbers, is the model tests, right? That's like the core of the application, and that's the part that's important to test. Other tests are great as well, but I don't think UI specific testing is as useful. It also takes more time to write typically, and so the trade-off is less useful. Testing is your friend then, right? Testing is your friend. It saves you future pain. Right? You spend the time now, write your test, and then it will save you down the line. At my company, when I joined, we had 0 testing, which was a huge problem because we want to release software. How do you ensure that it actually works? And it was a very manual process. QA would have to test it, engineers would have to test it and make sure that, manually creating new accounts, clicking buttons, it all works. And so the rule we had was anytime you touch any part of the code base, you have to also test it, right? And so rather than spend like a few months writing out all these tests and everyone losing motivation and not coming to work, we said, all right, there's a bug or there's a new feature. When you fix it, write a test. And over time, right, what that meant is everything that we touched had some tests. And so our testing coverage went from 0%, slowly rose, and over about a year, it went up to like 75%, which is pretty decent for not having to spend a significant chunk of time on itself. So we still were able to build out new features for the business while maintaining some testing. And nowadays, the companies, we can, on the server side, I feel pretty confident when we write new code that it's not going to break old things because our testing suite is fairly comprehensive. So the rewards definitely pay off, when you have a good testing suite, because then you can pretty quickly, with confidence, say if your code works or if it doesn't. It's always embarrassing when you think it does, and then someone has to tell you it doesn't, right? And then like a user or QA, someone's like, that doesn't work, and you're like, what? Like I tested it, right? Like, did you test every scenario? Probably not. Is there a test for it? There should be. So now you write a test. So testing definitely saves you embarrassment and the pain of having to go later than write a test for it and fix it. So testing is very key to good software development. To view the coverage. Yeah, so SimpleCov, I believe it provides an HTTP site you can hit. Um, I think you gotta just add this code in, right? And it basically looks like this. It's a pretty easy to use UI, and it'll show you like if you click on a file, what lines have been executed via testing, and what lines have not. Um, so you could shame the partner who didn't write test to their file. But you can start to see, oh, this stuff is essential to this model, but it's not being tested. We should probably fix that. Um, right, and here it looks like the device functions uh, aren't tested very well. I mean, it's just an example. But it kind of tells you, oh, in these files, how much of the code was tested, and then overall, how much coverage do I have on my files. Um, so yeah. Alrighty.